Okay, so now we have a couple more formulas to derive here. And the formulas that we have are basically cos x plus cos y. Cos x plus cos y is equal to basically 2 times cos of x plus y divided by 2 times cos of x minus y divided by 2. And we have cos x minus cos y is equal to negative 2 times sine x plus y divided by 2 times sine of x minus y divided by 2, right? And then we have also sine x plus sine y, which is equal to basically 2 times sine of x plus y divided by 2 times cos of x minus y divided by 2. And of course all of these would be in parentheses too. I mean, it would be better if we put these in parentheses. And then you have sine x minus sine y, that is equal to 2 times cos x plus y divided by 2 times sine of x minus y divided by 2. These are the 4 formulas that we want to derive, and these are all based on the formulas that we had before, so there is really nothing new here. So now let's give ourselves a little bit more space. 263. Okay, so now previously we said that cos of x plus y, is equal to cos x cos y minus sin x sin y. Let's call this equation number 1. We also said that cos of x minus y is equal to cos x cos y plus sin x sin y. Let's call this equation number 2. Now if we add and subtract 1 and 2, adding and subtracting 1 and 2, we get, now adding means that adding them together, subtracting means that subtracting 2 from 1, right? Now if I add them together, I'll get cos of x plus y plus cos of x minus y. That is equal to, if you add these two together, these two will be cancelled out, meaning that sin x sin y, negative sin x sin y, positive sin x sin y, and then you will end up with 2 times cos x cos y, right? And subtracting 2 from 1, you will get basically cos of x plus y minus cos of x minus y. You will have, basically, if you multiply a negative sign here, you will get negative cos x cos y, negative sin x sin y, and then these two will be cancelled out. So then you will have negative 2 times sin x sin y, right? So I can call these, for example, equation number 3 and equation number 4. Now, we said that basically, further, let me write this a little bit back so that we said that also previously, we said that basically sine of x plus y is equal to sine x cos y plus cos x sine y. And also we said that sine of x minus y is equal to sine x cos y minus cos x sine y. So I can call this equation number 5, for example, and call this equation number 6. Now if I add and subtract 5 and 6, adding and subtracting 5 and 6, we have, so if I add these two together, I'll get sine of x plus y plus sine of x minus y. Adding these together, these two will be cancelled out, so I will have 2 times sine x cos y, right? And if I subtract 6 from 5, I will have sine of x plus y minus sine of x minus y. So then multiplying negative sign by this, these two will be cancelled out. So you will get 2 times cos x sine y, right? So I can call this, for example, equation number 7, equation number 8. Now, if I, so what we can work with now is equation number 3, which is cos x plus y plus cos x minus y, and cos x plus y minus cos x minus y, and number 7 and 8, which is sin x plus y, sin x plus sin x minus y, and number 8 here. So if we say that, for example, let x plus y is equal to, for example, some angle like theta, and x minus y is equal to some angle like phi, for example. Therefore we have, so if x plus y is equal to theta, then finding these in terms of what is x and y here. So if I add these together, meaning that if I write x plus y is equal to theta and x minus y is equal to phi, if I add these two equations together, these two will be cancelled out. I'll have 2x is equal to theta plus phi, which implies that x is equal to theta plus phi divided by 2, right? And also the same two equations, if I write them as x plus y is equal to theta and x minus y is equal to phi, and if I multiply this whole equation by a -1, so I write x plus y is equal to theta and multiply this by -1, negative x plus y is equal to negative phi, that gives me basically x and x cancelled out, and so you have 2y is equal to theta minus phi, which means that y is equal to theta minus phi divided by 2. So here I can write, basically I can write x is equal to theta plus phi divided by 2, theta plus phi divided by 2, and y is equal to theta minus phi divided by 2. So that's basically what we can get from here. And then what I can do is that basically we said that in equation number 3 equation number 3 was cos of x plus y plus cos of x minus y. So equation number 3 becomes cos of x plus y plus cos of x minus y. So we said that cos of x plus y plus cos of x minus y is equal to what? Is equal to 2 cos x cos y. 2 cos x cos y. 2 times cos x cos y. So x plus y is equal to theta, right? X plus y is equal to theta. So let me put some rectangles around these so that we understand them. Okay, so x plus y is equal to theta. So that means that cos theta plus cos of x minus y is equal to phi is equal to x is equal to theta plus phi divided by 2. 2 times cos theta plus phi divided by 2 times cos of theta minus phi divided by 2. That's one equation that we can have here. And in number 4, equation number 4 was cos of x plus y minus cos of x minus y is equal to negative 2 times sine x sine y. So equation number 4 was cos of x plus y minus cos of x minus y is equal to negative 2 times sine x, what was that? Sine x sine y. So what that means is that basically cos of x plus y, which is equal to theta, minus cos of x minus y is equal to phi, is equal to negative 2 times sine of x, which is theta plus phi divided by 2, times sine of y, which is theta minus phi divided by 2. That is also what we get here. Now in 7 we said that basically x sine of x plus y, so I write it as sine of x plus y, which is equal to theta, plus sine of x minus y, which is equal to phi, is equal to 2 times sine x, which is theta plus phi divided by 2, times cos of y, which is equal to theta minus phi divided by 2. That is also one thing that you can get. And in 8, so we have sine of x plus y, which is equal to theta, minus sine of x minus y, which is equal to phi, is equal to 2 times cos x, which is equal to theta plus phi divided by 2, times sine of y, which is theta minus phi divided by 2, right? So that is basically what you get here. Now, you can appreciate the fact that basically theta and phi here can take any real values, meaning that there is no limitation on theta and phi here. So you have cos of theta plus cos of phi, and cos, and here you have cos and sine and so on and so forth. So you can say that since otherwise you would have to basically take care of the limitations, right? So since theta and phi can take any real values, we can replace theta by x. We can replace theta by x and phi by y. And thus we get, so if I replace theta by x and phi by y, I will get basically cos x, for example, plus cos y is equal to 2 times cos of x plus y divided by 2 times cos of x minus y divided by 2. I would also get cos basically cos x minus cos y. Cos x minus cos y is equal to negative 2 times sine of x plus y divided, so cos theta x phi y, so negative 2 times sine x plus y divided by 2 times sine of x minus y divided by 2. And also basically over here you would get sine of sine x minus sine y is equal to 2 times sine x plus y divided by 2 cos of x minus y divided by 2. And also you will get here, you will get sine of sine x minus sine y is equal to 2 times cos x plus y divided by 2 sine x minus y divided by 2. Now, one thing that you can appreciate here is that deriving these formulas is not easy. It takes it takes a whole lifetime. It's actually taken over 4,000 years. It's taken mathematicians over 4,000 years, meaning that today we talk about mathematics in terms of simple things like class 5, class 6, class 7, 8, 9, 10, 11, 12, and then we have an engineering degree or a bachelor's degree, then we have a master's degree, then we have a PhD. So now, well, of course, you can argue that, well, I mean, back then, like 2,000 years ago, or 1,000 years ago, or even 300 years ago, there was no engineering, there was no really technology, there was nothing. But but mathematicians had worked up to probably class 12, and then all of this science and engineering and technology and everything has been created by humans in the last 300-400 years or so. But even up to class 12, it's taken human beings like 4,000-3,000 years to develop all of these formulas and all of the basics and all of the foundation of mathematics that we have. And you can see that it's not easy to do that. I mean, it takes thousands of lifetimes to do that. So one thing that when you derive a formula, first of all, you can appreciate that, and you can appreciate the wealth of knowledge that we have today as a result of all that each and every mathematician and scientist has done for us so far, which is of course amazing. And secondly, once you do the derivations, this is the process of mathematics, really, meaning that if you want to become a mathematician, then of course that would be that would be what you would spend the rest of your lifetime on. So that's basically that. Now, So these are basically what we wanted to achieve. This is what we wanted to achieve, and then there is another part here that is also needs to be understood, and there is 4 more formulas that you can derive from these formulas. So as you can see, what these formulas do for you is that you have some angle x, you have some angle y, and you have and basically if you calculate the cos of that angle, the first angle, and take the cos of the second angle, for example, then that is going to be equal to the 2 times, for example, the cos of the average of those 2 angles times the cos of the, for example, x minus y divided by 2, right? So this way you can basically put those 2 angles together and add them together and divide by 2, take the cos of that, and again you can put those 2 angles together in this manner. And so here you can see that cos and cos are being multiplied together. So here there is multiplication. Again here there is multiplication. Again here there is multiplication. And again here there is multiplication. But here you have, actually this is supposed to be sine of x plus sine of y is equal to 2 times sine of x plus y divided by 2 times cos of. This is supposed to be addition. I made a mistake here. So here you can see that you have basically the cos of this angle plus the cos of this angle, and that gives you basically, and then you have put those 2 angles together in this manner, and again put those 2 angles together in this manner, and then you can basically multiply the 2 things together, meaning that it's going to help you solve many types of problems. For example, when there is the cos of some angle plus the cos of some other angle, you can express the same thing as the product of some form of the same 2 angles. Again, when you have the cos of some angle and the cos of some other angle, and when there is subtraction, again you can express the same thing in terms of multiplication. Again, addition, multiplication, subtraction, multiplication. Now there is one more thing that you can do here, and that is you can basically do this the other way around as well, meaning that you can, for example, if I take this first formula here, for example, cos of x plus cos of y is equal to 2 times cos of x plus y divided by 2 times the cos of x minus y divided by 2, right? So what I can do is that I'm going to say that, for example, I'm going to say that, for example, x plus y is equal to x plus y divided by 2. So let for example x plus y divided by 2 is equal to theta, and x minus y divided by 2 is equal to phi, for example, some 2 angles, for example. And then what I can do is that I can write basically form a system of equations. X plus y divided by 2 is equal to theta, and x minus y divided by 2 is equal to phi. And what that gives me, and I can simplify this a little bit, I can write this as x plus y is equal to 2 theta, and this one implies that x minus y is equal to 2 phi, right? And then if I solve these equations, that gives me 2x is equal to 2 theta plus 2 phi. And then I can simplify this as 2x is equal to 2 times theta plus, this is actually phi, right? So that is basically 2 times theta plus 2 times theta plus phi. And then I can simplify this, and that gives me x is equal to theta plus phi, right? Theta plus phi. And also the same thing, the same set of equations, I can write it as x plus y is equal to 2 theta, and x minus y is equal to 2 phi. And for example, take the second equation. This is the first equation, I write it as it is, x plus y is equal to 2 theta. The second equation multiplied by a negative sign, so negative x plus y is equal to negative 2 phi. And if I now add these two equations together, I will get 2y is equal to 2 theta minus 2 phi. And that means that 2y is equal to 2 times theta minus phi. And these two can cancel, and that gives me y is equal to theta minus phi. So which means that basically, basically x is equal to theta plus phi, and y is equal to theta minus phi. So now I can use the same equations that we had before, meaning that, for example, cos x plus cos y. So here we had cos x plus cos y is equal to 2 times cos of x plus y divided by 2 times cos of x minus y divided by 2. So I can write this now using this information. I can write it as cos of x is equal to theta plus phi plus cos of basically y, which is equal to theta minus phi, is equal to 2 times cos of x plus y divided by 2 is equal to theta, and times cos of x minus y divided by 2 is equal to phi. Which basically means that 2 times cos theta times cos phi is equal to cos of theta plus phi plus cos of theta minus phi. So I can write it this way. And then in order to make it more, well, appealing, you can say that, for example, 2 cos x cos y is equal to cos of x plus y times plus cos of x minus y, right? And some people write this formula as cos x cos y is equal to 1/2 times cos of x plus y plus cos of x minus y. You can do that as well, of course. But that's basically the base formula that you would get. Now, what this formula does for you is that you have some angle x and some angle y, and this is the product of the cos of the two angles. And then you can express that in terms of the sum of the cos of some form of the two angles basically put together, meaning that cos of x plus y plus the cos of x minus y. So this is going to be helpful in many different types of situations. And so let's forget about this form. But of course, you can always derive that on your own. And there is also cos x minus cos y. There is also cos x minus cos y, which is equal to negative 2 sine times sine, negative 2 sine x plus y divided by 2 times the sine of x minus y divided by 2. And here we said that basically x is equal to theta plus phi. So I can write x as theta plus phi, and over here I can write negative cos of y, which is theta minus phi, and that is equal to negative 2 times sine of x plus y divided by 2, which is equal to theta, and times sine of x minus y divided by 2, which is equal to phi. And then I can write the same formula as cos of basically x minus x plus y. Instead of theta and phi, I'm going to use x and y, minus cos of x minus y is equal to negative 2 times sine of x sine of y. Right? So that is basically another formula that we have. Moreover, you can use the third formula, which is sine x plus sine y. Sine x plus sine y, which is equal to 2 times sine times cos. 2 times sine x plus y divided by 2 times cos of x minus y divided by 2. Now this is equal to, now we said that x is equal to, over here x is equal to theta plus phi, y is equal to theta minus phi. So the sine of theta plus phi plus the sine of theta minus phi, and that is equal to 2 times sine of x plus y divided by 2 was equal to theta cos phi. And now if I substitute basically x for theta and y for phi, I will get sine of x plus y plus sine of x minus y is equal to 2 times sine x cos y. Right? That is another formula that we will get here. And the next formula is sine x minus sine y. Sine x minus sine y is equal to 2 times cos sine. 2 times cos x plus y divided by 2 times cos of x minus y divided by 2. Now, x was equal to theta plus phi, so I can write this as theta plus phi minus sine of theta minus phi is equal to 2 times cos x plus y divided by 2 is equal to theta cos phi, and then I can substitute basically x for theta, y for phi, and I can write this as y sine of x plus y minus sine of x minus y is equal to 2 times cos of x cos of y. That is another formula that we have now. And so that is basically 2 times cos x cos y is equal to cos of x plus y, 2 times cos x cos y, there's something wrong here, right? 2 times cos x cos y is equal to cos of x plus y. Two times sine x. 2 times sine x cos y is equal to sine of x plus y plus sine of x minus y. This is correct. I might have made a mistake here. Sine x minus sine y is equal to... Oh, that is a sine, I'm sorry. This is supposed to be a sine. And this is supposed to be a sine, and this is supposed to be a sine. So 2 cos x sine y, 2 cos x sine y is equal to sine x plus y minus sine x minus y. This is also correct. And 2 times sine x cos y is equal to sine x plus y. 2 times sine x cos y is equal to sine x plus y plus sine x minus y. That is also correct. And negative 2 times sine x sine y is equal to cos of x plus y minus cos of x minus y. This is also correct. And 2 cos x cos y is equal to cos x plus y plus cos x minus y. These are all correct. So we got another 4, you can say, or 8 formulas, which is basically based on the same formulas, but these must be practiced a little bit so that you learn them, and they must be, well, preferably committed to memory. So let's do a review here. Let's do a summary here. Let's do a summary here, and then we will finish this video, end this video. So we had basically cos x plus cos y is equal to 2 times cos of x plus y divided by 2 times cos of x minus y divided by 2. We also said that, this is number 1, we also said that cos x minus cos y is equal to negative 2 times sine x plus y divided by 2 times sine of x minus y divided by 2. This was number 2. We also said that the sine x plus sine y is equal to 2 times sine x plus y divided by 2 times cos of x minus y divided by 2. And that was number 3. And number 4, we said that sine x minus sine y is equal to 2 times cos of x plus y divided by 2 times sine of x minus y divided by 2. So that was a part of these formulas. Let me make a screenshot here. So I will call them trigonometric part 5. Call them part 6. And then the next part, we said that we said that 2 cos x cos y, we said that number 1, 2 times cos x cos y is equal to cos of x plus y, cos of x plus y times plus cos of x minus y. We also said that negative 2 times sine x sine y, is equal to cos of x plus y minus cos of x minus y. We also said that 2 times sine x cos y, 2 times sine x cos y is equal to sine of x plus y, plus sine of x minus y, plus sine of x minus y. We also said that 2 cos x sine y, 2 cos x sine y is equal to sine of x plus y minus sine of x minus y. And that was number 2, that was number 3, and that was number 4. So let me check these formulas. 2 cos x cos y, negative 2 sine x sine y, 2 times sine x cos y, and 2 cos x sine y. And you have cos x plus y plus cos x minus y, cos x plus y minus, and sine plus sine, sine minus sine. Okay, they are all correct. And that becomes the last formulas that I suppose we derive here. Okay, so now that is basically the end of this part. So in the next video we will basically talk about the properties of inverse trigonometric functions. We will use all of these or some of these formulas in deriving some of the properties of inverse trigonometric functions. I'll see you in the next video, and thank you.